Hey there folks, Mr. G here with another educational video. Today we're going to be talking about atoms. So we've been talking a lot about chemical, physical properties and matter. Today we're going to dive into what actually makes up matter. And that starts with talking about atoms. Before we jump in though, make sure you put the date as well as the page number. This is the 5th page of our notes for this unit. And let's dive in. So you might be wondering how we actually know that matter is made up of atoms. So we've talked about atoms and molecules a little bit last time when we were talking about mixtures. But how did we discover these? How were these discovered in the first place? Well, it starts with something called Brownian motion, and I'll include a link for a video about showing what it is and what it looks like. It was first discovered by Robert Brown and then applied by evidence of atoms by Albert Einstein. And basically what it was is if you put particles of pollen in water, they'll kind of bounce around and move around randomly as if they were alive, as if they were moving on their own. The conclusion that Einstein came to was that the pollen must be moving because of water molecules colliding with it. So that's some evidence that the water itself is made up of tiny little molecules. The other piece of evidence that we have for the fact that matter is made of atoms and molecules is the scanning tunneling microscope. Which allows us to use electrons to find the edges of atoms. It kind of like bombards the atoms and shoots electrons at it, and you can see where the edges of atoms are by kind of feeling around, like feeling around for the edges of an object in the dark. We can use it to see the shape of atoms and molecules. Now, the atom is the smallest particle of matter that still has physical and chemical properties of the substance itself, so it's kind of like the smallest piece. If we think about water, the smallest piece of water is the water molecule, which would have 2 hydrogens and 1 oxygen. But we can break this apart into even smaller pieces. Even if we talked about an atom, a simple atom like oxygen, we talked about how that was an atom itself, we can break up the atom into even smaller parts. And these are what are called subatomic particles. These are the particles that make up an atom. So these are the pieces that make up an atom. These include protons, neutrons, and electrons. So the symbol for our proton is P or P+. It has a charge of +1. It's in the nucleus, and it has a relative mass of 1,836 if we make the electron equal to 1. Similarly for the neutron, it has no electric charge, neutron. It's in the nucleus, and it is just ever so slightly bigger than a proton. An electron, E or E-, has a negative charge, and it's outside of our atom, or it's outside of our nucleus. It's in the energy shells, and it has a really tiny mass compared to our proton and our neutron. A very common picture that you'll see for this, oftentimes the protons are represented with pluses, neutrons are represented with little zeros, and then our electrons are represented with little minuses. And what you'll see oftentimes in pictures, inside our nucleus are a whole bunch of protons and neutrons all packed together, and then orbiting around it in these energy shells are electrons. So you have these little negative electrons, and they're zipping around the outside of our atom. And we'll talk about this in a little more detail in next lesson, and you'll learn a lot about this in grade 9 and grade 10 science. But for now, all you need to know is that our protons and our neutrons are inside our nucleus, kind of at the core in the center, and the electrons are zipping around the outside. Our protons are positive, neutrons are neutral, electrons are negative. Our nucleus, that's the middle part here, which we mentioned, is the extremely small and dense center of the atom that's made up of protons and neutrons, so this center bit. The energy shell or energy levels are regions where electrons orbit around the nucleus. Orbit just means that they spin, and electrons in further away energy shells have more energy. So the farther they are away, the more energy that they have. The electric charge of something is a physical property that causes it to experience electrical forces. So you've probably felt this before if you've ever played around with like the friction rods where you rub it with some sort of material and it picks up an electric charge and you can use it to attract or repel things. And electric charges can be positive, negative, or neutral. Again, neutral, neutron, no charge. And the rules are that opposite charges attract and similar charges repel. So if we have a positive and a negative, they want to move together. If we have 2 positives, they want to move away from each other. And just as a little aside here, you might be wondering like, okay, in this picture, the nucleus looks pretty big compared to the size of where the electrons are orbiting around. But in the real world, if the nucleus was the size of a hockey puck, the atom, the whole atom itself, would be the size of an entire hockey stadium. So this is a really very, very small center of our atom. The electrons are zipping around in a very large area around our nucleus. So our first question is, what is the charge of an atom's nucleus? Well, if we look at what makes up a nucleus, it's a bunch of protons and neutrons. So the charge of an atom's nucleus is equal to the number of protons. If atoms have the same number of protons and electrons, and this is true, all atoms do, there's always an equal number of protons in the center compared to the number of electrons that are going around it. What is the overall charge of an atom? Well, it would be the number of protons. Those are positive. And then we would subtract off the number of electrons. These are our negative, so all our protons are positive, all our electrons are negative, right? And that's why we subtract them here. And if there's an equal number, then the charge of the entire atom needs to be 0. All of the positive charges in the middle are canceled out by all of the negative charges that are zipping around in the form of our electrons. And as it turns out, we can break down some of our particles even further beyond protons, neutrons, and electrons. So composite particles, composite just means that it's made of components. That means that it just has multiple parts. So a composite particle is something that is made up of smaller parts, and that includes atoms, protons, and neutrons. We saw that an atom is made up of electrons, protons, and neutrons. And as it turns out, protons and neutrons are both made up of something called quarks. So our elementary particles, these are the ones that can't be broken down into smaller things. So if our composite particles can be broken up into smaller parts, those smaller parts are going to be our elementary particles, the ones that can't be broken into anything smaller. And there's a big table here. I don't expect you to memorize all of this, but I want to show you all the different sorts of weird elementary particles that exist. The first one are our quarks. So these are the things that make up protons, neutrons, along with a lot of other stuff. There are 6 flavors, so 6 different types. There are leptons. That includes our electron, muon, tau particle, electron neutrino, muon neutrino, and tau neutrino. So the electron, muon, and tau are all very similar. They all have negative charge, but they're just different sizes, different mass. These neutrinos are really hard to detect. They're super, super small. They have no charge, right? Neutral, neutrino. And trillions actually pass through our bodies, and that's because they're so small and they have no charge. The last type of elementary particle we're going to talk about are bosons, and there are tons of different types of bosons. These particles are carriers of force and energy, so they basically make forces work. So for instance, the gluon binds quarks together, photon is particles of light. These bosons here, the Z and the W, manage the strong and weak nuclear force. The Higgs boson, this is responsible for the mass of particles. The graviton is responsible for gravity, although we haven't discovered it yet. And there's actually even more examples of different types of bosons here. Now, if this feels a little overwhelming and a little weird, that's totally normal. This is the sort of stuff that you would be learning about in university. But I want to introduce it to you and show you that it's not just atoms, protons, neutrons, and electrons, that there's actually tons of other types of particles that exist that allow you to break down these composite particles even further. So for example, protons and neutrons are made up of quarks. Protons have 2 up quarks and 1 down quark. Neutrons are made up of 1 up quark and 2 down quarks, and then they have some bosons. In particular, these are usually gluons, and this is what helps bind our quarks together. These gluons create something called the strong nuclear force, and this is what holds our nucleus together. But why would we need something to hold our nucleus together? Why wouldn't these quarks just kind of hang out together? What's wrong with that? Well, if you think about our protons in our nucleus, right? Remember, our nucleus is made up of a bunch of protons and neutrons. Well, we talked about how when we have 2 positive electrical charges that they want to be away from each other. right? They want to get away from each other as much as they can. So we need this strong nuclear force to keep these positive charges together. The key here is that protons with positive charges are going to repel each other. So we need this strong nuclear force to keep these protons together. The last question here is what words would describe the type of particle that an electron is? Well, let's go through it. Subatomic. Subatomic means that it's what makes up our atoms, so this is definitely true. Next one is composite. If you remember, composite particles have multiple pieces inside of them. We had a list of a few composite particles, and then we had all of our elementary particles. And you'll notice that our electron is in this giant list of all of our elementary particles. So it's definitely elementary. You can't break it up. That means it's not composite. Composite means it's made of more than one piece. Elementary means it's just made of one piece. It's the smallest piece. So it's, in this case, elementary and not composite. And then quarks, leptons, bosons. You remember those are the three main categories here. And you'll see, based on our diagram, they are a lepton, which means they're not a quark and they're not a boson. That's the end of our video here. I know this is a lot of different terminology, and I want you to focus not on remembering all the different types of things, but just sort of the larger ideas. Right? The main points for this are that there are atoms, and then particles that make up our atom, protons, neutrons, and electrons. Definitely want to remember these three, which one's positive, which one's negative, which one's neutral, how big they are. And don't focus too much on memorizing all the different types of quarks, leptons, and bosons. Thanks for tuning into the video. Please make sure you check Teams for all of the homework, assignments, and other activities that I'm having you do today, and I'll see you all in the next video.